Hi everyone, I'm Kawawa and this is Made Simple with us. Don't forget to subscribe to our channel for more videos like this. Today we are going to discuss on the determinants of 2x2 and 3x3 matrices. In this video, we are going to deal with the step-by-step method on how we can solve for the determinants of 2x2 matrix and also solve problem in 2x2 matrix determinants, and also we are going to discuss on how we can arrive at 3x3 matrices determinants and also problem and solution. So let's start with determinants of 2x2 matrices. Determinants of 2x2 matrices. So let's start from here. We say the determinants of a matrix, for example, if we are given a matrix A and the elements of matrix A, which are A, B, C, and D, is defined as determinant A. So in other words, they are saying, not in all cases we will find the word determinant. Sometimes we notice or we actually giving determinants in a sign. For example, if we see they say find the determinants of a particular matrices and the elements are given, and that particular matrices is being noted by the sign, a straight line like this sign also means that they are asking us to solve for the determinant of that particular matrices. So in this case, we are given a matrix and the elements of A, which are A, B, C, and that's also find the determinant. So how are you going to find the determinant of struct? We say we multiply the corresponding elements. That is, we multiply A to D minus D to C. This is how we find the determinants for 2x2 matrix. We call this 2x2 matrix because it has 2 column and 2 row. So the general formula for determinants of 2x2 matrix is, so the determinant of A now going to be noted as A determinant now could be equals to A multiplied by D minus B, minus B multiplied by C. So this is going to be written as AD minus BC. So this is the general formula we use to solve for the determinants of any given 2x2 matrix. So let's take a real example here. We are given example A. Example 1, we are given the matrices of A and the elements, which are 5, 7, 2, 3, and we are also given B and C. So in this example, I will always take one example and solve, and you guys are going to solve the remaining 2 examples. So if I'm going to take, I'll choose C. Example. I'll choose C. We are given C as 4, minus 2, 1, and 7. And they say we should find the determinant of C. That's why I said sometimes you may not see words like determinant itself in spelling, but these signs indicate that they are referring to the determinants of that particular matrices. So remember I told you that the general formula is we multiply the corresponding element and we subtract them and also multiply the other corresponding element. So in this case, the determinant of C is going to be now, the determinant of C is going to be, remember I said we are going to multiply the corresponding element, so we are going to multiply 4 by 7 minus, and then we'll see what, minus 2 multiplied by 1. So that's the formula. So this is going to be 4 multiplied by 7 minus into what is here? Minus 2 times 1. To be good. So the determinant of C is going to be 4 times 7 is going to give us 28. And remember there is sign here, so take note of the sign. So minus 2 times 1 is minus 2. So this is going to be minus into minus 2 times 5 is going to be minus 2. So this continue again. So the determinant of C now is going to be 28. Minus times minus is going to give us plus 2. So this is going to be 30. So the determinant of C is going to be 30. So this is how you solve for 2x2 matrices. This is how you solve for the determinants of 2x2 matrices. So follow the step and follow the rules. In mathematics, you always follow the rules. You always follow those steps in arriving at your answer. Remember, this is Made Simple with us. We are here to simplify and make things very simple so you guys can understand. So I hope you can solve the remaining two as I'll be moving on to the determinant of a 3x3 matrix. The determinant of a 3x3 matrix is kind of tricky compared to the 2x2 matrix. Kind of tricky. But there are some rules, there are some steps you must follow, or if you follow those steps and those rules, you are going to solve any given 3x3 matrices. One of the rules is we first derive the minor. So I'll explain what is the minor. The minor of the selected row or column element. Step 2, we exclude the row and the column elements in the minor. So here they are saying, in finding the determinant of a 3x3 matrix, we must first of all derive the minor from the row to that of the column. So, and after we derive the minor, we now exclude the row and the column elements in the minor. So they are saying here, if we are going to find the determinant of 3x3, we are going to consider any 3 given a row or column, each of which you choose is going to work, irrespective of the position you take them from. So if I'm going to find the determinant of 3x3 matrix, I will first consider, let me just take this first row, A, B, C. Let me use this to find the determinant. So they're saying, if I'm going to choose any 3 given row, you are going to find the minor of each element in that row and you take them out. To those elements, you are going to multiply for the determinant, and by that you can arrive at your answer. So if I have chosen A, B, C as the 3 column, or the 3 elements that I would choose from the column to find the determinant, then it's going to be, we are going to find the minor for A. We are also going to find the minor for B. We are also going to find the minor for C. And after which we use the 3x3 sign, the minor sign. But I'll get there. So let us take for A. Let's find the minor for A. So how are you going to find the minor for A? If we're going to find the minor for A, let's say we are now discussing on A. This is what we want to find the minor for A. The rule is saying, once you have chosen that particular element in which you want to determine the minor, in order for you to arrive at your determinant in 3x3 matrix, we now consider this particular element A, the row in which A is connected and the column in which A is connected. We exclude those rows, meaning we take them out. Whatever that is remaining, it is known as the minor of that particular element. So let's say now I have chosen A, and I want to find minor. So now let's ask ourselves, in which column does A connect, and also the row in which A is connected? So if I'm going to choose first the row, A is connected to this first row, which is A, B, and C. A is connected to this row. And also A is also connected to this column, A, D, and G. So this is column. So once you determine where A is connected, in which row A is connected, and in which column A is connected, you take them out. Whatever that is remain, it is going to be the minor of A, the minor of that particular element which you have chosen. So if I have taken the row, remember we have taken the row out, A is connected in row. And remember one thing also, in each of these elements in this matrix, in 2x3 matrix, get this in your mind that it is always connected by row and also column. It is a must. It must connect with row and a column. That particular element. So if I have taken the row out and I've taken the column out, what is remaining here is the minor. And the minor is going to be now, so E, F, H, I. This is known as the minor for A. Because when you have taken the row out and you have taken the column out, what is left? It is E, F, H, and I. So that's the minor for A. So if you can see here, this is why we have A into E, F, H, I. So this is the minor for A. So now let's move again to B. Let me just take this out. Let me take this out. Let's move again to B. Remember, we are still from A, B, C. You can choose any three elements. So we have dealt with A. So now let's move to B. Let's say we want to find the minor for B. We follow again the same procedure. And get this in your mind that always any element in the 3x3 matrix is always connected by a column and a row. So determine the column in which that particular element is connected and also determine the column, take them out, whatever that is remain. After you have taken the column and the row out, it is known as the minor. So if I will now connect B, you can notice that B is connected to this first row. And it's also connected to this second column, which is B, E, H. So once you have taken these two out, what is remaining here is known as the minor. So the minor now is going to be what? D, G, F, I. D, G, F, I. So this is the minor. You will not consider again EH because EH is connected to B as the column, and you will not also consider AC because it is connected as row. So what is remain? That's how we have B to B, D, F, G, I. This is the minor for B. And again, if we move on now to C, let's now find out in which row does C connect and the column is connected. And we take them out, whatever that's remain, it is known as the minor for C. So again, remember, we are still considering for the three elements we have chosen to find our determinant, which is A, B, and C. So if we are now looking for the minor for C, then let's make C the subject. So if we make C the subject, and let's find out which row does C connect. We can notice that C is connected from this row. And it's also connected from the third column, which is CFI. So we have taken A, B, C out, and we have also taken CFI out. So this, if we have taken, let me just wipe something. Okay, if we have taken this out, this, assume you're not, seeing, then you just assume this is blind. So when you cover these two, what do you see? What is left out? Whatever that is left out is known as the minor. And the minor here for C is going to be D, E, G, H. So the minor for C is now D, E, G, H. So this is how you always determine the minor. So you can go on if you want to practice now, and you go and find the minor for the remaining elements, for more understanding. Find the minor for the remaining elements. So if you've noticed, I've done that, but So save time, you practice this on your own. Now the next step is, after you have determined the minor from the three chosen elements, you now apply the sign of minor rule, meaning the sign minor rule of 3x3 matrix. The sign minor rule of 3x3 matrix, it is always plus, minus, plus. The next one, if this is plus, is the next column is going to be minus, plus, and this is minus, and this is going to be plus, minus, and it's going to be plus. So take notes of this sign. They are very important in determining the determinant of a 3x3 matrix. They are very, very important. So this is one example, and this is the sign rule. So you take note. For example, in this first aspect here, I have chosen ABC as the minor element, this one. ABC to find the determinant. So yeah, if I have chosen ABC to find the determinant, what will be the minus sign supposed to be here now? Now remember, this is the minus sign. We have plus, minus, plus. This is the first column. So if I have chosen the first column, I mean row 1, and the signs in row 1, it's plus, minus, plus. So meaning you are going to place the signs in front of the element. It's going to be plus, minus, plus. So now let's take away our problem and let's solve so you can see. Example. And then now to build this example, let me just do this. Let's say we are asked find the determinant of let's say find determinant of y. Determinant of y if y is equals to, let's say 1, 2, 3, 5, 6, 7, 8, 9, 4. If y is equals to 1, 2, 3. Okay, so this is 3x3 matrix, and we are asked to find the determinant of y, and they are giving us the elements of y. So if we are to find the determinant of y now, remember the first rule is saying that we first of all derive any three elements. It could be column or it could be rule in which you want to find the determinant, and after which we find the minor of each of those three elements, and we use the minor signs, not the 3x3 minor sign. So this example is 3x3 matrix because it has 3 rows and 3 columns. So let me just go straight solution. So we are going to find the determinant of this. Let me just take it out. So again, this is y, and the element of y now we are giving us 1, 2, 3, 5, 6, 7, 8, 9, 4. So if I were to find the determinant for this, first of all, I will choose again the first row. I'm going to use the first row to find the determinant. This is what I choose. For you, if you want, you can choose the third row, whatever case, whatever method you want to use, or you might choose the second row. You still arrive at the same answer. So for me, for this particular video, I'm going to use the first row, row 1. So I'm going to use row 1 to find the determinants of 3x3 matrix. So I've done the first step, that to choose in which row you want to use to find the determinant. Now the second step is in each element of that row, you are going to find the minor of that element. How many elements do we have in this row? We have 3 elements, that is 1, 2, and 3. So we are going to find the minor of each element. And remember I said, in determining the minor of each element, we now, okay, let me go. Let's say I want to determine the minor for 1. So in determining the minor for 1, I'm going to ask myself two questions. The column in which 1 is connected and the row in which 1 is connected, we determine that, and after which we take them out. Whatever that is remained, that is the minor for that particular element. So if I'm making 1 the subject and we want to find the minor for 1. So let me see, where does 1 connect? 1 connects with this row. This is the row 1 connects, and it also connects on this column. So this is the column, and this is row. So once you have determined the row in which 1 is connected to, and you've also determined the column in which 1 is connected to, the remaining elements in the 3x3 matrix, the remaining elements that 1 is not connected in that row, or neither is connected in the column, that particular element, those elements, they are referred to as the minor for 1. Are we getting it? So the minor for 1 is going to be 1. Remember, we'll also consider the sign, the minus sign. So for this first element, it's always positive. Let me just state it for simplicity. Plus 1, the minor element is going to be 6, 7, 9, 4. So this is a minor element for 1. I will just use this sign and indicate it for simplicity. So we have now determined the minor for 1, which is the first element in the 3 elements we have chosen to find the determinants. So we move again to the second element, which is 2. So the second element here is what? 2. So also for 2, we determine in which row does 2 connected. 2 connected from this row, and also connected from this column. So once you determine the row and the column in which that particular element is connected to, you take those out, you take them out. Whatever that is remain, it is known as the minor. And also take note of the sign. So if here is minus, then 2 now is going to be what? Minus 2 into, then we take the minus out. What are the minor? The one that's 2 is neither connected to the row and the column. So the minor here is going to be 5, 7, 8, and 4. So this is the minor. Alright? So we'll move again to 3. So for 3 again, we do the same thing. We ask ourselves, which row does 3 connect? Of course, 3 is connected. 3 is connected to the first row and also connected to the third column. So once you determine the row and the column in which it is connected, whatever that is left out, it is known as the minor. And be careful of the sign. So if here is minus, it's going to be plus what? 3 into. So what's the minor? The minor here it is 5, 6, 8, and 9. These are the minor. So once you have determined the minor, then you go ahead and proceed in finding the determinants. So after we have determined now the minors, and we have also caution of the sign, that's why the signs are indicated in color red, so you guys can understand better. So the next step is we are going to find the determinant of each of these minor that is connecting with the elements. So remember, in finding determinant, this has now led us to what? 2x2 matrix determinants. Remember, this 2x2 matrix determinant now. So what is going to be that? So we are going to multiply 6 by 4. We are going to multiply 6 by 4. And then we subtract again and multiply 7 by 9. So are we getting it? So we go again, be careful of the sign. So this is going to be now plus 1 into, so we say what, 6 times 4 minus 7 times 9. Once it is closed, we go again, minus 2 into 5 times 4 minus 8 times 7. So this again is close. Then we're going in plus 3 into 5 times 9 minus 6 times 8. Minus 6 times 8. So we proceed. So this is how you always find the determinants of 3x3 matrix. So we move again. So this is now going to be So if we say that 6 times 4, so this is going to give us 24. So it's going to be plus 1 into 6 times 4, it is 24, minus 7 times 9 is going to give us 63. Remove again, minus 2 into 5 times 4, this is 20, minus 8 times 7, this is 56. We go again, plus 3 into 5 times 9, it's going to give us 45, minus 6 times 8, it's going to give us 48. So we continue. This is always what's plus 1. I'm just indicating the sign for simplicity. So 24, we now clear the brackets, right? Okay. We say no, 24 minus 63. It's always negative. Minus 39. Then we go again, minus 2 into 20 minus 56 is going to give us minus 36. Go again, plus 3 into 45 minus 48. This is going to give us minus 3. So we now multiply each element into the bracket. So plus 1 plus times minus, it is minus. 1 times 39, it is what? 39. Minus times minus, it is plus. 2 times 36, this is 72. I hope we are understanding the signs and how they work. Minus times minus, that's what we have plus here. So going in plus times minus, this is always minus, and 3 times 3, this is 9. So we now put them all together. So you're going to be down minus 39 plus 72 minus 9. So all of this is going to give us 24. So meaning the determinant of y determinant is 24. So this is a determinant for y. This is a determinant. And this is how you find any given 3x3 matrix determinant. I'm Kalawa, and this is made simple with us. Don't forget to subscribe to our channel.